Our next speaker, Bill Stockton, is Executive Associate Agency Director and a Senior Research Fellow at Texas A&M Transportation Institute and Chief Research Officer at this institute. His principal liaison to the Institute of the largest research sponsor, the Texas Department of Transportation, and oversees TTI's interdisciplinary research activities. Dr. Stockton has launched numerous research efforts that have become key sustained programs of research, safety, countermeasures, intelligent transportation system strategies, managed lane feasibility, border crossings, solutions, toll road viability. Recently, Dr. Stockton has focused on projects that develop public policy tools that has served as a staff director for Blue Ribbon panels. His current focus is on high-level leveraging of research across disciplines and sponsors. During his 40-year public career, Dr. Stockton has led a wide array of disciplines, from medical providers to civil engineering, white-collar executives to blue-collar field crews, with exceptional success in high employee morale. His awards include the Charlie V. Wooten Award for Career Achievement in Research, as well as numerous research and public service awards, and 6 individual commendation medals from the U.S. Army. Dr. Stockton holds a PhD and Master and a Master of Engineering and a Bachelor of Science in Civil Engineering from Texas A&M University. He's a licensed professional engineer with the state of Texas and a graduate of the Governor's Executive Development Program and active member. So let's hear about transportation now.
Thank you very much, Jim. We'll probably go from the fairly advanced kinds of discussions we've seen today, and I'm really impressed. As a citizen, I've learned a lot, and I really appreciate the invitation. Challenges that you've talked about include energy and water and education and health, and I want to suggest that we can add transportation to that as a major challenge that will be faced in the future. And for today, I want to focus not on the challenge of commuters and congestion in major cities, but really on how are we going to provide enough freight to serve 50 million people by 2040 or 2045. It's a real honor for me to be here. Let's find my little remote here. When we talk about freight, we're talking about virtually everything we do. Consumables like groceries, durables like home and office furniture, buildings, highways, fuels, nearly everything involves the moving of cargo somewhere. The movement by barge, pipeline, railroad, airplane sometimes, and most ubiquitously trucks. Trucks are the most flexible and dynamic of the freight modes. It's the one that we're most familiar with. In many cases, it's also the one that we fear the most. 67 tons of freight are hauled every year per Texan. That amounts, and most of that, by the way, is by truck. That amounts to roughly 1 18-wheeler per person per year. If you think about the amount of trucks on Texas highways now, and as a driver or a passenger, you're very familiar with trucks. Imagine doubling that number in the not too distant future. So there'll be some significant advances in technology that will help mitigate that growth. And I want to tell you about 3 areas of research that we're doing at Texas A&M Transportation Institute that I think will make measurable differences in the impact of truck travel in Texas. First, in the area of data to improve supply chain. Second, in the area of technology to make truck operation itself more efficient. And finally, in an entirely new mode of transportation for moving freight. So for those of you that don't know anything about the Texas A&M Transportation Institute, let me tell you just a little. We are one of 3 research and service agencies that, along with the College of Engineering, form the engineering program at the Texas A&M University system. I don't know if Dr. Banks is here, but she is the Vice Chancellor for Engineering, and all of these entities report to her. With more than 400 full-time professionals and an annual research expenditures approaching $70 million, we at TTI are the largest university-based transportation research organization in the country. In addition to participating faculty from every college on the campus at Texas A&M University, including liberal arts, we have nationally renowned professionals on our staff with expertise ranging from engineering to economics to epidemiology. Our primary sponsors are public entities, as Jim mentioned, including the Texas Department of Transportation, the United States Department of Transportation, and a very large sponsor of ours is the National Academy of Engineering. Our business is applied research, translating new science and new technology into practical solutions to wicked problems. So let's move back to trucks. As an engineering-based institution, the first thing we want to do is define sustainability. Our Dr. Joe Zietzman has authored the National Academy of Engineering's principal guidance on freight sustainability. And for simplicity, I'll use the definition of the net effect on the environment, which is primarily ecosystems and human health, on the economy, specifically in this case on the cost of transport and those costs that are passed on to society, and then finally on societal cost, which is really in the arena of safety. And all of those dimensions whoops, wrong button. All of those dimensions are built into all of our analytical approaches. By the way, the quote at the bottom belongs to a very close friend of mine who's responsible for logistics for a very large grocery company in Texas. So let me talk a little bit about data. Historically, make sure I get it right. All right. Historically, we counted trucks and we knew where the traffic was heavy, and that was about it. But the explosion of data availability is having a profound effect on freight movement by truck and on how we, the public sector, facilitate trade. The 21st century, Dr. Bill Isley, who you see on the left, is one of the national leaders in conceiving and refining the use of data such as real-time data based on origin, destination, real-time weather, traffic, etc., to allow for the routing of vehicles. Also for the big picture of the freight network, so that discussions focus on multi-state solutions rather than just on an individual route between Houston and College Station or between Odessa and Fort Stockton. What are actual travel patterns of freight in the country, in the state, and how do we maximize that? The other person I'll mention is Dr. Juan Carlos Villa. Juan has used data and persuasion, frankly, to dramatically streamline the efficiency of border crossing operations in the U.S. and southern borders. I personally would credit him as having more impact on border crossing operations in the United States than any other single, or actually in North America, than any other single individual. Real-time border information systems allow both users of the system as well as the inspection agencies to make real-time decisions on resources, routing, timing, etc. And it's had a significant impact on the efficiency of the crossings and is being adopted by federal agencies. But in spite of the things that we either know or can know, there's quite a bit about trucks that we don't know. We can know about the load, the driver. We can know about the origin and destination and onboard data. What we don't know is what's on board that vehicle. And if we knew that, we could operate the system better, and arguably we could provide even better security against malicious actors. But the margins in the business are very slim. And so data becomes something that's of high value to trucking operations and to shippers, and they guard that very jealously, and so far they're not allowing us to make use of that. And that represents a really important balance that occurs in a lot of what we do. If you think of the trucking industry and the airline industry are a lot alike. They use public infrastructure but they conduct private business there, and they don't want the rest of us messing in their business models, and they do expect the public sector to make maximum efficiency of the system that they operate. One future goal that we have is to develop a secure information sharing regime that safeguards private interests, but at the same time enables the public entities to do a better job of developing and managing the facilities that these private sector entities use. Let me pause just a minute about the modes and give you a few stats that might be of interest to you. This gives you a sense of the magnitude and impact of trucking in Texas. 67,000 tons per person per year. As I mentioned, the majority of that by truck. 600,000 truck trips per day in Texas. 25 billion truck miles per year. That's a bunch of times to and from the moon. It's not a small part of the employment base. 4 million employees, and it has more than a $50 billion economic impact on the state of Texas. One takeaway here is going back to what I said earlier. We're a growing state. For every 1,000 person growth, net growth in population in Texas, that's 1,000 more semis, at least on the trajectory we're on right now. So let me talk about another project that we have. It's a fascinating research project underway on our Rellis campus, which is our research campus in College Station. There we go. As you can see from this video that we did last year, there's one truck following the other with absolutely no control exercised by the driver in the trailing vehicle. That's him right there. The two vehicles talk to each other via onboard systems, and those are augmented by an array of sensors and high-resolution GPS. So you might ask, why would we want to create an electronic version of tailgating, if you will, by 80,000-pound vehicles? Well, fuel and drivers are the most expensive aspects of trucking, and platooning promises to have significant impact on both of those. For the fuel savings approach 10% to the two vehicles combined because of the aerodynamic effects that it has on both vehicles. Drafting, if you will, if you happen to be a NASCAR fan, that's what we're getting out of this for both vehicles. And as it relates to the drivers, federal rules of service limit the productivity of drivers. And if we can, in fact, demonstrate that the driver has a lower workload, we may be able to change some of those rules and get more productivity out of the drivers that we have. Dr. Beverly Kuhn and Mr. Mike Lucas are leading a public-private team that is going to demonstrate not only the technical feasibility, but to identify when and where it is safe to allow platooning. And I might mention, this is an industry-driven activity. This is not something we're trying to create. The industry is going to do this. So when and where is it safe? What are the best practices? And what kinds of safety restrictions should be in place? I might mention just briefly that there's a current trajectory in technology that is going to start showing up actually this calendar year in the newest models of Cadillacs, and that's an onboard DSRC, dedicated short-range communication radio that will allow that vehicle to talk to another vehicle. That's what these trucks are doing right here. It will also allow that vehicle to talk to a traffic signal and know when the signal is going to change to red, and prevent crashes between vehicles. There's a key ruling coming up from the Federal Communications Commission on the sharing of the radio spectrum that those radios depend on. If that spectrum is shared, then that creates essentially an existential problem for this kind of technology, which will actually force the industry to back up and find another way to do this. So we're anxious to see what the FCC might choose to do. I want to close with one of the most interesting and dynamic things that we've done. It's a game-changing signature development called the Freight Shuttle. This innovation has been in development for almost a decade by Dr. Steve Roop. It incorporates unique attributes of both trucking and rail. It's very low maintenance, it's very low energy, and it's envisioned for private sector financing, development, and operation without a public sector cost. That photo at the right is the operational Alpha vehicle that's on our test site northeast of the Texas A&M campus. The Texas A&M University system has spun off a company to complete the development and initial deployment. In the following video produced by the company, it's a little bit of a promotional slant, but it provides a good explanation of the concept.
Introducing the first cost-effective, energy-efficient, environmentally friendly freight transport system. Until now, hauling freight was a costly, time-consuming business involving the inefficient use of trucks, highway congestion, air pollution, damage to public roads, and a threat to public safety. Now, there's the innovative freight shuttle system. It moves truck trailers and containers via transporters in the medians of highways or other rights-of-way over distances of up to 500 miles on elevated guideways. The system is composed of 3 primary components: electrical single-unit transporters, elevated guideways, and convenient terminals. The system provides reliable, predictable point-to-point delivery of freight with 0 emissions and no interruption of traffic. GPS and wireless communications, in conjunction with a fiber optic backbone, will provide a constant flow of information on status, position, and operating conditions, enabling exceptional command and control of the entire system for maximum safety and efficiency. Transporters are designed to easily accommodate either containers or semi-trailers, which are loaded quickly, depart immediately, travel to their destination on electric-powered guideways at 60 miles per hour, and arrive as scheduled every time. The entire guideway system is elevated with no at-grade crossings. There are no delays due to surface traffic congestion, and operation is safe because passenger traffic and pedestrians never interact with the system. State-of-the-art overhead construction techniques ensure that no roads will be closed and no drivers inconvenienced while the guideways are being erected. Terminals are designed for maximum efficiency, reducing time delays in loading and unloading of containers and trailers. Easy exit and entry from the guideway makes the operation seamless with virtually no interruption of traffic flow. Terminals are modular, so lanes and capacity can be easily added as demand increases. Specialized terminals in select locations, such as ports and borders, scan 100% of the cargo for security without disrupting the movement of freight. The privately funded freight shuttle system is based on the innovative and patented application of existing and proven technologies.
The physics of steel wheel on steel rail, like the railroads employ in their operations, and is really one of the keys to railroad viability, offers such superior rolling friction, a fifth or so of what rubber tire on pavement offers, that any high volume, high weight, low cost system simply has to look at steel on steel as part of the engineering design.
What Dr. Roop has done is ingeniously put several technologies together for the first time to create a system that we believe will function and function very well for freight movement, but is not Star Wars or space age, because these are technologies that exist and are being used in places today.
Practically everyone benefits from the new freight shuttle system. Trucking companies will experience more cost-effective deployment of trucks, less downtime for drivers, and greatly increased fuel economy. Shippers will save time and money with more predictable pickup and delivery times. The driving public will experience less traffic congestion, reduced air pollution, and improved highway safety. And local, state, and federal transportation agencies will save millions of taxpayer dollars on road and bridge repair. The freight shuttle system is ready to launch a new era in the efficient shipping and delivery of cargo, ready to move freight into the future.
This is the actual vehicle itself on one of its very early test runs at the Northeast Bryan campus. The noise you hear is mostly the wind out there. But anyway, it's a low-speed test. We were really pleased to have Governor Abbott come to college, or come to Bryan, actually, is where that campus is, and be there to press the button to start the first public event to demonstrate the freight shuttle. The beta vehicle for this is well in design. It will be shorter. In height, it will be shorter in length, and it will be substantially lighter, allowing us to use smaller linear induction motors. So, well, that's too fast. Don't go there yet. The most immediate application for the freight shuttle appears to be at the Texas-Mexico border, where you in fact could take shuttles that are carrying previously inspected and cleared cargo, whether it's a container or a semi-trailer, over the border on an elevated guideway, missing all of the border traffic and connecting between terminals in the two countries, likely manufacturing plants such as in Juarez, Mexico, and El Paso, Texas. We believe that would reduce both the cost to the shipper as well as significantly and reduce emissions in that area. So we talked about three different kind of innovations that are ongoing in the work that we're doing at the Texas A&M Transportation Institute. Innovation and ingenuity have driven development of freight cargo in the United States for the last century, and we certainly expect that will continue. The information age and the explosion of the data from Internet of Things will spawn significant changes, some of which we've talked about today and some of which we don't know anything about as yet. Let me introduce you to the freight research team at TTI. These are our innovators. I know that I speak for them in saying that we intend to bring about dramatic changes in freight mobility, all the while ensuring sustainability in the environmental, social, and economic implications of those technologies. So I thank you for the opportunity to share some of this with you, and I'll be glad to do as you see fit, Jim, taking questions as appropriate. The question was, have we estimated the lives saved by removing trucks from the road? Well, let's take, for example, first, how many trucks could you remove from the road? With a single facility, like in the I-35 corridor, you would remove about 9,000 to 10,000 trucks per day. A substantial decrease in crashes, probably a more improvement in mobility in the corridor than even in safety, but it would be substantial. I don't know. We haven't not estimated the lives saved. Yes, there's a question.
Yes, I think it's an excellent idea. It looks actually quite appealing. But my question is, couldn't you also combine that monorail system for taking, big trucks from the road to do a fast passenger train that may connect, say, different airports along I-35, and that would allow many commuters, use a lot of this time that we spend driving, an hour and a half and so on, or 3 hours going to, from one way to another, to get into a very fast mobility for passengers. Because you can do a double-deck monorail that could sustain two different speeds and two different services.
That's a great suggestion. Her suggestion was that we actually use this for passenger transportation, and we've talked about that. We've talked about developing a pod that has really comfortable seats and Wi-Fi and whatever other kinds of amenities passengers might want to allow for a shuttle from Dallas to Austin, for example. And so I brought this up to Dr. Roop, who is the inventor and the developer here, and he said, please let me move one box of freight before you have me start bringing people into it. But I think he realizes that too.
But you could put cars with people and freight them that way, actually.
I think he's open to all of that. That's a really good suggestion. Thank you.
A simple question. Why only 60 miles an hour? Why not much more?
I think they can, well, for one thing, I think they want to make sure that the structures they are building we keep the cost of the structures as low as we can to make this as financially attractive as possible. The higher the speed, the more the loads would be, and I think that's one of the reasons. Plus, the speed also determines the horizontal and vertical geometry. So we want to stick to a geometry that is very compatible with the existing roadway geometries.
So if this works and is efficient, why are you not advocating to just replace the entire freight railway system with a monorail?
It is probably at certain distances and weights, it is not a good replacement for rail. Rail has a very, very high efficiency in terms of bulk cargo, for example, and there's probably not much room to compete. And it's also not much room to compete over distances, say, beyond about 250 miles. We can go farther than that, but it's not terribly competitive, at least right now. After we've done a little bit of this, we may change our minds. Thank you very much.